Well, welcome, Brandon Pearson. Thanks so much for sharing some time with us this afternoon. Tell our listeners a little bit about who you are and what it is that you do with space.
Yeah, definitely. So, like I said, my name's Brandon Pearson, and my original background comes from teaching. I've been a high school science teacher for the past 7 years, mainly teaching things like biology, anatomy, and those things. But I first really got invested into the whole area relating to with atmospheric and space science by 3 years ago at my current school, where we went and created an advanced STEM class. And in this class, students would go and would design experiments that we would send up on high altitude balloons. So they would come up with different things where they would go and be sending some maybe biological things. They'd maybe be testing different elements in the atmosphere, that kind of stuff. And we would send that up 100,000 feet. They would analyze the data, make revisions, and do it multiple times as well. So in the process of doing that, I got connected with the group that was doing those things, which is called NearSpace Launch. And NearSpace Launch has a history of doing small satellites and cube satellites and those things as well across education, industrial, commercial, government, all those different things. And a part of that has also been through using balloon launches as well. But a cornerstone of NearSpace Launch has been education. So I started coming on board to help them see, hey, how can we take the heritage that NSL has with all of their system in space, balloon launches that they have done, and bring it down to the high school level and lower levels even more from there. So I jumped on board. I just got brought on full-time this summer now as the director of what is called NearSpace Education. And NearSpace Education is a sidearm of NearSpace Launch, and eventually going to be a whole separate company altogether, where it's a nonprofit that focuses on STEM education relating to atmospheric and outer space stuff. So if we're looking at things like balloon launches, thin sats, CubeSats, all those different things all come from that same part.
So a teacher theoretically who is able to bring something smaller into the classroom, like starting with a CubeSat, a high altitude balloon, could eventually stay with your company in all the way to building a CubeSat. Is that correct? Like from start?
Yeah. So we've been started working on the process is called Steps to Space. And the idea is to be able to go and to start with what you have right in the lab. So maybe it's just learning how to program some little sensors and those kind of things. And you start with that at a basic level. But from there, you go and you move your way up to, okay, let's take the sensors we programmed and now let's fly it on a balloon and throw in some other things as well. So for example, we had a group in here actually from Kevin who went and came up with some kids from Florida. And they went and came up with some different ideas of experiments that they were able to go into tests, including things relating to with soda, and there was some other little chips in there in terms of seeing about some communication ability, and then flying down on the balloon, but then taking that information and the skills that they have learned from there and transferring that to the next level, which is to build it as a satellite. And there kind of be this gap, people have this mindset of that, hey, outer space, satellite, those things, that's way beyond what I could do. I could see myself doing a balloon launch. I for sure could see myself programming a classroom, but getting that into space, there's a break there in terms of what it could be. But it's really actually pretty doable to keep moving step by step. So everything that you do in the room and then that you're doing at the balloon launch, you're adding in a few extra things and then the requirements that need for space as well, but you're able to do a very similar process all the way through. So
if we drop some teacher talk, teacher speak, we'd say it's a great way to scaffold the learning from the entry level to the expert level in space. I have just a quick follow-up question. When you were teaching your class, were you flying only biological payloads in your high school HAB class or your high altitude balloon mission?
No, we've had it all across the spectrum. So I've had people who have gone and they've flown experiments to test the effects of sound as you go up. So we've flown little sensors that are reading a distance using what's called a ping. So it would bounce off a barrier and come back into a receiver. And they would basically was the rate of sound being impacted at all during the flight. So we had sensors send out a signal, bounce off a barrier, picked back up by the sensor again. And as it went up, they actually noticed that distance increased with altitude. And there's some reasons, they were able to analyze, was it temperature? Was it because of less air pressure? But I've had people do that. I've had people create egg drop capsules to try to go and see if they can get an egg to survive the whole thing, which they were able to do many times successfully. But they're still looking for that first time where they can get one to survive without a shell. They would dissolve the shell off of it and then try to rebuild a capsule, and they couldn't get that to work. But that is something my students have kind of picked up from that every year. We've had people who've done biological stuff like growing bacteria. We've had people who've flown seeds and then planted them and got back. testing different levels of sunscreen to see which type would work in the intense UV environment up there. Quite a wide spectrum of opportunities across different sciences.
Right. So the high altitude balloon was merely a tool that you could use for any number of teaching topics.
Yeah, in my mind, I use it as a way of going and teaching the basic skills that students need to go and be able to develop. So, you talk through things like the scientific method. And if I introduce just the scientific method, you're going to get a whole bunch of kids that are either going to make groaning sounds or like, you got to be kidding me. There are some that get really interested in that stuff, but the basic things are used there, being able to identify a problem, use knowledge that I already know to come up with a solution, start to design a solution, go and actually conduct the test, and then analyze how it went after. Those are transferable skills you're going to use in any number of types of jobs. So I have a bunch of people who take the class that have no interest in science or a science background, but they're really interested in what we're doing, and they're using those same skills that are just key problem-based skills that you're going to use in any number of different curriculum or a number of different educational backgrounds later on. So it's a platform to teach the skills that help make students successful, whether they're going into STEM careers or not.
Right. So I'm thinking like back to when I was were you working for a public or private school when you first started the high altitude balloons?
Private school.
Okay, because I'm thinking like one of obviously some of the options that, or rather the obstacles that a teacher might have to bringing even high altitude balloons into the classroom is going to be cost, which of course with the high altitude balloons, they're much more affordable than a CubeSat, but at the same time, the lack of knowledge about how to assemble it. So it sounds like you're solving one of those problems by forming NearSpace Education. You're going to put the bits and pieces in to make it teacher friendly with the curriculum that goes along with that. But how can teachers afford to bring something like this into the classroom? Are there grants, et cetera?
Right. Now, it actually gets to be, when you talk about cost-wise compared to things, it really doesn't get to be nearly as expensive as what you're talking about other stuff. I mean, you're talking about for a few $1,000s, you get the opportunity to have the equipment yourself that you can keep flying over and over again, which if you look at a lot of these main STEM programs people are selling nowadays are all within that exact range as well. There are grants that are available through different state education funds that are there. There's grants available from private levels. But then another thing that we've started looking into is, hey, can you get sponsors that jump in on these kind of things? For example, my school has gone and we got sponsors to sponsor each one of our balloon launches, and then we flew something of theirs on the balloon as well as a part of a publicity thing. So, hey, not only do you get to go and check a box saying that you're increasing the education of the community, but you also are now getting some free marketing as well, because you're getting the opportunity to go and to take something of yours and fly it up 90, 100,000 feet up in the air. And now we got footage of your item along with the curvature of the earth and outer space as well.
Right. So it's just a willingness then to figure out, okay, this is something I want to do. And I think it was great that you had the freedom to actually design an entire course around that, as opposed to trying to still meet like certain curriculum requirements and then trying to squeeze it in. But I think, like one of the things that Kevin and I were talking about with high altitude balloons, as we're getting ready to head to Athens to present on it a little bit, was that they are also more, I think, attractive to teachers because they can be done way more quickly. Like a CubeSat's going to take 2 to 3 years. And yeah, you learn a lot in that process. And that's the true nature of project-based learning that I think sometimes we, forget, but they're done in a day, but the lessons can go on well after when you're collecting the telemetry.
Well, and part of what you're talking about, one of the things that you mentioned, that idea, I'm trying to remind back to, because there was something you say and I lost it for a second, but you're right in terms of the idea of it just going and building off of each other. Like you can talk about a small level where you can just have somebody come in and launch an individual balloon, which has got one hand of its own learning experiences. But one of the things, and this is what I was going, you were talking about relating to the standards and the content level. Well, there is a bigger and bigger push across the country and in individual states. For example, I live in Indiana, and Indiana has gone and started a mission several years ago to really focus in on STEM education. And there was lots of resources and training that got poured into that kind of stuff. Well, then you also see the development of like the next generation science standards. You see the generation of 21st century content skills that are being taught as well. Those kind of things, these things where we're finding out that, okay, students can learn content, but they don't know what to do with the content. So you can pass a test, but you don't know how to apply it. And these are things that I'm in a master's program right now that focuses on STEM education with curriculum instruction. And one of the classes we just finished was talking about the idea that students can learn the content, but they can't apply what they're learning to real life situations. And there was a whole new aspect that's been added to education of trying to apply that. So there's what are called the SEEPs, which are the Science and Engineering Process Standards. And basically they line up perfectly with the steps of the scientific method. Can you identify a problem? Can you use what you already know? Can you create a solution? Can you test it and analyze the results and make revisions? You can teach all of that easily in 1 week when you're doing something with a balloon course. And you can throw in content standards as well. If I want to teach about the life cycle of plants, let's fly some seeds and see what happens. You know, there's so many different options you can add on top of that, while also teaching what I would argue is more important, those soft skills that people need to succeed.
Right. We're big fans on both soft skills and what you said about can you identify a problem, come up with a solution, build the apparatus, test. You know, that's right in line with also entrepreneurial startups, right? You're also teaching not only these great soft skills for kids to work in groups and teams and come up with a great deliverable, but you're also teaching them how to start their own companies one day. You may not call it entrepreneurial training, but that is exactly what you're doing. And we're right in there with you on real world applications and applying what you know.
Yeah, and oftentimes, like even when I first started working with Kevin, and my role was to kind of train the kids that had this content area to actually kind of speak about it, right? I didn't know anything at all about CubeSats, and I thought aerospace basically meant, oh, they want to be astronauts, right? And I think that's the level sometime at which many, not just students, I think many adults kind of come from. Until I went to MIT on a trip with them, and I realized, okay, no, there is something for every single person within this industry. No matter what your passion is, you can find it here. And so I guess what I wanted to just kind of where I was going with that eventually was that when we finally spoke to the Office of Science and Technology Policy, and they were talking about little kids, you've seen them all talking about CubeSats, right? And they were, even back then, that must have been what, 2017?
2018.
Talking about how do you replicate that? Like, how does our educational system replicate what you're doing? So it's good to hear. I don't know that it's the same, obviously, in every state. We certainly have challenges in Florida that are different from others, but it's good to see that there's a movement to use STEM the way it needs to be, not just a phrase that's thrown about,
Well, excuse me, sorry. You're looking at a field that's going and exploding more and more all the time, as we're seeing an increase in needs for technicians. We're seeing an increase in needs and stuff relating to aerospace, as we talk about GPS, sensors, all these different areas as well. And you're right, there is the stigma behind it that if you talk about space, you either got to have the last name Bezos or Musk, or you're going to have something relating to NASA or another group if you're going to do that. And part of this was even a mindset, even as a teacher, that I had myself, because I was able to, during that balloon class, I was given the opportunity for us to fly our own sensor board on a ThinSat as well. In one of the launches back in 2021, when NSL did a ThinSat mission where they launched over 30 different student ThinSats at the same time. And the idea was like, oh, that's way too beyond the reach of what we have. No, it's actually extremely, extremely doable and scalable compared to what it used to be. And there is variety in terms of just how creative you want to get as well. If you want to do something with a CubeSat, like you guys have done so much, I know with Kevin's group that he's done through his training to go and to create these CubeSats and let the students really come up with more creativity as well. But then you can also have it at a simple level as well of, hey, we have the technology, we have the boards, you let us know what kind of stuff that you want them to do, and we have some flexibility from there that we can go and we can just send it up if you just want to have something in space, and you can have the opportunity to analyze the footage as well. So you have a range of where it's not just the giant massive satellites and you need to have all these engineering degrees. There's all the support along the way that can get anybody who's interested in that level, as long as you're willing to learn and willing to take some risks in terms of, hey, let's go and push ourselves beyond what we don't think is possible here and get creative.
Right. And I'll brag on you guys. Everyone that listens to us knows I'm a big fan of NSL. And
he's
NSC.
Usually wearing his NSL shirt for all of these.
It needs to be washed, so we're wearing a different shirt today. But I literally thought the high altitude balloon was a beautiful pathway, right, to the CubeSat for things like the radios. You can have a very similar radio that uses the Global Star Network, and using the dashboard there with the kids is really teaching them how to use the satellite dashboard. Mm-hmm. And I think the beauty and the simplicity and the beauty and why you're going to be so effective is the common board, right? If you have a board that you can fly on a balloon, that is also the board that the programming board, the board to be accessorized or put your modules on it and then fly it on a ThinSat, man, that all that institutional knowledge you built in with your balloon program with a group of kids, that immediately transfers to ThinSat and maybe even CubeSat. So I think that is a really good selling point for NearSpace Education is the NSE board. I don't suppose you have one handy that you could hold up for the for our podcast?
For our podcast viewing the day after this drops.
Never be afraid. So Brandon's holding up a board for our listeners. He's pulling out an NSE
Once
board.
I go and get once I want to have here, I got this is one of them, and I'm looking for the other one that attaches to it. So give me just 1 second.
Because those were thin sets, right?
we tried to get it.
That's right.
So he's holding up a board, and the beauty of this is if you program it, you can fly that on a thin sat and a high altitude balloon. Am I correct on that?
That is the plan for what we have, is being able to take something like this that has the basic programming abilities. You can go, and this one here would fit right inside a regular thin sat. Have your viewers seen what a thin sat looks like?
We definitely have some broadcast stuff, yes. And
Okay.
For our listeners, I would call that a little bit longer, but about as wide as a credit card. Probably.
Yep. So you have a small board. It's got all the processing abilities, and you have sensors on here with UV, temperature, environmental, a number of different options on there for things you can do. There's also custability to go in to put on additional things such as GPS, grid eye, and particle detectors. But then you go and there's a secondary one. The two meet together, you attach it right on. And then this one includes all your environmental sensors on the bottom that just clips right into place of the top board. And then now you're looking at things like a GPS system that you can fly separately on your balloon. You're looking at an environmental sensor that gives you temperature, pressure, altitude, all those different things as well. But what got me, so I had done stuff on balloons. I'd done it for the last 2 years. And then they came to me and said, hey, would you guys be interested in flying a thin sat? And I'm like, are you kidding me? I have no clue about programming. I have no clue about where to even begin with making a board. Remember, my background's in biology, and then I switched to teaching. So I haven't had this kind of experience in it before. I love being creative and I love trying new things. But at the same time, with work expectations and the requirements, I was overwhelmed by trying to learn an entirely new, different career that I've never gotten into. But then they came and said, no, we have an option for you in place where you go, and it's the same thing that you can fly on the balloon. It's already got all the sensors on there, and all you have to do is decide what kind of code you want to upload to it. I'm like, that's something that I can take and I can run with. That's significantly less overwhelming. My students can do, and I can still analyze the data from there. And that is what we're going, and we're trying to make more and more, is those kind of easy connections in terms of that kind of stuff. So
I mean, that you made it look like, and maybe it's just because, again, I remember I'm the English teacher of the group, right? So for me, but it looked pretty simple. Like apparently you've made it such that all that a beginning teacher, like a rube, so to speak, could be able to put something together and test it. They don't have to do too much behind it. And if they can't do any at all, you can actually do it for them, is what you're saying.
Right.
So you provide
there's the flexibility. There's the flexibility to go, and what part of what the goal we have is to be able to take, whenever you go and you have something started up, you're providing the supplementary material. So you get the teachers in there who are really, really ambitious. Kevin, who goes and are willing to jump out and stuff and run with those kind of things on their own and have the background, the expertise, that's fantastic from there. And there's those group. But what about the people who would love to do this kind of stuff, but also easily get either they're overwhelmed, they have way too much on their plate already. The expectations out there. I mean, I don't know about other people out there, but I went and I had 5 different classes. I had 5 separate preps that I taught every single year. Yeah. So, in that case, when you're looking at all those different things, how do you incorporate this? But through additional support, training, provided curriculum, that kind of thing, providing the equipment, there's a range in there depending on, hey, what do you feel comfortable with? And the goal is to let the kids run with it as much as they want. Yes, it's great to have the teacher do it, but at the same time, giving it to the students and letting the students be able to run with the entire program is such another level. That student-centered classroom, to throw out a teacher word here from training wise, letting the students go and have them learn the materials, have them make the mistakes. I can know the background to try to support them in as well, but I really want them to be the ones to be able to do it, because that's where they're going to be learning the skills that are going to be successful for later on. And from that individual hands-on learning, that's when everything comes more alive.
No, absolutely. Right. And it's something that the younger we start them, I think a big mistake we make here in this country is we wait until maybe high school, definitely university, for people to start actually dabbling and working with people in the industry that they're interested in. Instead, we need to start much younger. I mean, we know that kids start to identify with how they see themselves, like, oh, I'm a math kid, oh, I'm an athlete or whatever, as early as ages 5 through 7. And yet we wait so long to start exposing them to doing the real work of something, So I think it's phenomenal. How are you going to market? So I want to know marketing. So I'm thinking about, again, back to when I was a public school teacher, and even now when I've worked with other teachers, how do you get the word out for the person who is probably like the one that you described, who's like, oh, it's a great idea, but I don't know anything about, and they assume aerospace means only one thing versus biology, et cetera, right? How do you get the word out to teachers that you're even there, or give yourself a plug?
Well, they just went and we just had our big grand opening of our new buildings, which was a big kickoff because we went from consolidating across 3 different buildings at different locations to one main center right here in downtown Upland, where we have both NSL and everything they're doing with the satellites, and then NearSpace Education on the other side that combines those 2 parts together. There's a Facebook page called NearSpace Education that we're putting new content on as this stuff gets going more and more. There is information in terms of on our website that we have with NearSpace Education as well, that we're constantly adding more things to as we develop this and get this more and more ready. And then you can start looking forward to when we start looking at different conferences. Definitely not a plug here for a conference coming up in October down in Florida, but there will be presentations that will be done at different ones there. In fact, here you go, Kevin, your conference card.
Yeah,
right here for your small sat education conference that we'll be at. We'll be at small sat in Utah. That will be going on here in August. We'll be doing that as well. And then from an educator perspective, I'm looking at the Indiana Education STEM conference taking place. There's other STEM conferences across the nation as well that we can get involved in, because I mean, that's where a lot of these things that this is where I heard about some of the stuff. And ever since I attended the first time, I'm like, hey, this is where we can keep going, pushing it more and more as well.
We just don't have anything like that
No,
down here. That's why
I think, well, we have something called the Florida Association of Science Teachers. There's an Indiana equivalent of that. Maybe NSTA, National Science Teachers. They have a lot of regional conferences. We're just a little late in the season, but
also things like AIAA educators, like you could advertise that in there.
Absolutely.
Well, there's also the main, there's the main STEM conference that takes place multiple times throughout the year, and that's a national program, and that switches from location to location. I can't remember the name of that group right now, but then there's also a conference that's done every year that's just talking about high altitude balloons, and that includes aspects relating to not only the academic portion of it, but also the STEM education aspect as well that takes place in Iowa. So they're out there. The thing that we've been working on now is to develop that product, develop that curriculum, the extra support we need. And now let's get this out there for people to see what NearSpace Launch has been doing.
Well, I know the kids really had a blast with you and the balloon that you mentored them through last couple of weeks ago. Also, we'll be plugging you guys at SmallSat, at COSPAR in Greece in 2 weeks, and in Paris, France at the International Astronautical Congress. So that's 3 conferences, in the next several months that you already have kids that are, happy to talk about the work that they did with you and the work they're doing. So as we're getting close to the end, I think of it, you made the joke that you're a biologist turned teacher turned space guy.
Yep.
I'm a biochemist turned teacher turned space guy. I just got about a 12 or 15 year head start on you. That's the only difference.
There we go.
Yeah. But and listen, I've enjoyed I think this has been a great interview. I'm sorry you couldn't get into a good community college. What's the name of that shabby school you're going to for your master's program?
For Purdue University?
Yes, you're going to Purdue.
Yes, having those level ones in there too. I'll make sure not to say anything about that in the town of Lafayette where I live.
Yeah,
I don't go and get shot. So
they produce quite a few astronauts. They're very well known. For our listeners, if you don't know, Purdue is one of the best engineering schools. A really great institution in West Lafayette. So
I'm just glad that somebody's finally working on this curriculum. I've known Kevin now for probably 7 years. And from the beginning, you could just see that there is an interest at the higher level. Getting it down to the teachers can be more challenging, but somebody's got to do it. So if you're going to be the first one to do it, that's good, because somebody else will do it otherwise. And it's the right time. Right. It's we've had a great team. We got great people involved. Kevin's students coming up and helping us with some of this boot camp stuff too was excellent people in there. We have great support staff in terms of professors that give input, people like Kevin who have taken with us and run with us and given awesome feedback. We're really excited. We're really excited to see what's going to come with all this too. And yeah, I'm excited to be able to go and present even more about this at the upcoming opportunities as well. Well, we always kind of close our interviews the same way, and I think it's going to be really well received today. So for our listeners who might be interested, especially maybe teachers or parents who have access to teachers who might want to bring high altitude to their class or high altitude balloons to their classroom, but are afraid, what advice do you have for those educators out there or those parents?
I guess the biggest thing I have is going and being willing to weigh the benefits as opposed to get the initial risks. A big part of what I'd always have is I would get immediately caught up by the obstacles. I would go and there would be an opportunity out there, and I would look at this and like, yeah, but all of these things need to happen, and there's no way that would all happen before getting to the end game. So they're not even willing to take the first step. And you have to be able to go and look to see that end goal of this is what I want my students to be able to learn. This is what I want my kids to be able to develop. And yes, there might be some things along the way, but once you start on that path, it's amazing to see how many of those obstacles are either a lot smaller than what you thought you're going to be, or even disappear completely, because our own tendency can be to go and just get overwhelmed in the moment. And part of our goal is to go and to reduce that overwhelmingness as much as possible by going and showing how easy it is to do. So be willing to go and take those initial risks and those kind of things, and have that vision of what this might look at the end in terms of what are my students or kids going to learn from activities like this, because that there is what drives you. When you get to that end moment and you can see that light bulb or that aha moment, the excitement they have, or when you can hear the success stories about how when students have used what you have done to help them get into colleges and programs and scholarships and jobs and that kind of stuff too, that's when what you're doing really, really becomes worth it.
Yeah, and I'm thinking too, like if for any parents who are listening, if you're able to think, we want to sponsor, go to your teacher, your student's teacher, and just say, listen, we're gonna together, we'd like to be able to do this for you. Can we at least set you in the right direction? Go to the website, right? There's a website. It's NearSpace Education.org. Okay.
Yep.
Yeah, go there and do that. And then I'm also just thinking, like, in general, the idea that there's going to be some failure along the way is something I think that we as teachers oftentimes have to recognize as a good thing. So the thing doesn't work right away when you send it up, and you got to try to reconfigure it or figure it out, or you have to try to get through the steps and take a little longer. But I'm also thinking about all the body of work and research that you could professionally do as a teacher related to this, like write a paper, present at a conference. You can probably build your professional resume as well at the same time as you're doing something.
Oh yeah, and there's so much to be learned that comes from failure. There's so many things that we go and that we pick up on in terms of, like, we don't like it when things don't go right. We don't like it if something takes place. But for example, you look in the aerospace industry, a lot of these major companies that we've talked about now, their first, multi-million-dollar rockets all exploded on their first launches. If I remember correctly, I think SpaceX had their first 2, if not 3 rockets explode before they even got one into outer space. And if you look at the number of the other ones, it's the same process as well. But are we willing to go and are we willing to take those things and say, okay, well, that didn't work. Let's go and try something different again. And that can teach you more there than almost any of the successes that you have, because you have to problem solve. You have to figure out what went wrong. You got to analyze and then take it from that. So you're spot on when you're talking about that idea with the value of failure.
In fact, aerospace, because it's so hard, we can bake in failure into the learning process where it's just normal, and that is the learning tool. So yeah. I thought that was spot on. We're real big fans in lowering your resistance to being willing to do the really hard things, because that's where all the good stuff is.
One last plug for your website where people can go to get information, and then we'll say goodbye.
Sounds great. So we go and we have our Facebook page called NearSpace Education here in Indiana. That's where a lot of our updates will be coming out from. We're going to be actually posting here in just a second on our Facebook page the highlight video from Kevin's group that went and came out here. So we have that from our grand opening, and also his space camp's going to be going out here within the next day on the website and then on the Facebook page. And then there's also the website as well.
Which is NearSpaceEducation.org.
All right.
Correct.
Thanks again for spending your afternoon with us. We appreciate it.